tell you about tonight are ideas I've had over the last 4 years. They're not very well worked out, but every time I speak, it helps me work them out, and your response will help me further explore these very, I think, radical and interesting ideas. So brace yourself for something new and different. Basically, what I'm going to tell you is that dreaming is our subjective awareness of the brain activation in sleep. And dreaming has been regarded as an unconscious mental activity, but it's not an unconscious mental activity. It is an altered state of consciousness. And if we change our definition or our thinking about dreaming, it changes everything. And this idea occurred to me about 4 years ago. I'm still trying to get over having been trained as a Freudian. And we've got to get rid of this notion of dreaming as an unconscious mental state. Dreaming is a state of consciousness which can't be remembered in the other state of consciousness, which is waking. So there's waking on the one hand and dreaming on the other, both states of consciousness, and very different from each other and very similar to each other. And then the minute you begin to think this way, then you can, I think, really begin to understand something quite different from what you expected to understand. And what I'm going to tell you about tonight are several aspects of this comparison of waking and dreaming, physiology of both states, psychology of both states, which lead me to believe that dreaming is a state of consciousness that actually it precedes and benefits waking consciousness. So dreaming, instead of being a derivative of waking, is in fact the progenitor of waking. Sleep comes first and waking comes second. And this is a very radical shift in emphasis. We have always thought that sleep follows waking, and of course it does. But it also precedes waking. So every night is followed by a day, right? As well as every day is followed by a night. But we have been exclusively interested in the way that the night follows the day, not the way that the night might anticipate the day. So in addition to trying to get you to at least consider the possibility that something like this might be right, that there are two states of consciousness, probably a lot more, but two very cardinal states of consciousness, dreaming and waking, and that they interact in a very positive and important way, such that waking consciousness actually depends on dream consciousness rather than the other way around. Now, if you take this point of view, then your scientific research is going to change very radically. And you're going to begin to think now about dreaming and waking as subjective states, which are similar and different. They're similar in that they are both very active, they're very dynamic states of the mind. But on the one hand, all of the sensory information comes from the outside world, waking, but from the inside world in dreaming. So the fact that the brain is able to create a simulation, if you will, then, of waking is an important part of my new theory. That what dreaming is doing, actually, is providing the brain with a virtual reality program that it uses in evaluating external reality. Now, the nice thing about this approach is that we can do a lot of work on phenomenology. We can do a lot of work on subjective experience, especially if we try get over the fact of interpreting the damn things. And we just have to get rid of Freudianism in all respects, and dreams are not to be interpreted. They're to be understood, defined, and measured, and compared with wake state consciousness. And so you can do a lot of formal analysis just with a paper and pencil. You don't need a laboratory even to do this sort of work. So everyone could be involved in studying consciousness, in studying dreaming, simply by paying attention to his own experience. And I really mean that this is true. And I think that the scientific opportunities of this sort of approach are enormous. And any psychology department or high schools or even junior high schools could be doing this sort of work. And I've just come from Lisbon, where I gave something like nine talks, 4 of which were just young school kids. And those school kids they're open-minded. I mean, they're ready to understand a new approach like this and jump in with both feet. They aren't being put off by being told that they're going to have to wait 20 years before they figure out what dreams mean. And the difference here is to emphasize the formal properties of dreams rather than the content. And let me tell you a little bit about what I mean by that. If for example, we were to ask what sorts of sensory experiences occur in the 2 states, we would be conducting a formal comparison. For example, as I told you earlier, in waking, we process information from the outside world. In dreaming, all of the information comes from within the head. So there is a source difference of the information that's processed. And those are formal differences that are extremely robust and very impressive. And for example, dreaming is very visual, extremely visual, which means that the visual system is capable of creating imagery that with the eyes closed in the dark, okay? That means that the brain is not only anticipating waking, but it's actually creating waking. A lot of 80% of dream content is in fact not a reproduction of experiences that have been had in waking. It is a prediction, a creative expectation of what might happen in waking. So that's one example. Another example is that in waking we remember quite well, but in dreaming we remember very poorly, and that's the reason for considering dreaming to be an unconscious mental state. It's simply unremembered when we're awake. That's the only real difference in terms of consciousness between the 2 states, is that one is remembered. Waking is characterized by rich memory, dreaming by exceedingly poor memory. So we have this contrasting situation in which waking is external reality, dreaming is internal reality. Waking is strong memory, dreaming is weak memory. And that's already a big step, isn't it? I mean, if we could understand the way that the brain engenders its own visual information and the way it arranges not to remember any of it, we'd be several steps ahead of the game. Now, fortunately, we're able to do this because sleep and dreams are not just a human phenomenon. All mammals have sleep and dreams, and they all have sleep that alternates between deep or non-REM sleep and light or REM sleep. And most of the dreaming that is very intense and scenario-like and hallucinoid is associated with REM sleep. So we have a physiological comparison then between the human and the animal at the psychological level and the physiological level, and we map back and forth between psychology and physiology. And we don't ask ourselves what the dreams mean yet. We ask ourselves, what are the differences in the subjective experience, and what are the differences in terms of brain activity, and can we make some sense out of those, of a comparison of those states? We've got brain states in both subjective conditions, and we have an animal model in which we could even ask questions at the level of cells and molecules. So I think the science of sleep and dreams is in fact the science of consciousness, and I don't know if it's the last frontier or not, but I think we've got our foot in the door, and the door is open, and we're starting to study the single most important aspect of our humanity, namely our consciousness, for the first time in recorded history. up until 20 years ago, all we could do was speculate about these matters. And that's not to say that philosophers haven't come up with some remarkable speculations. Freud is certainly one of them. Freud is a speculative philosopher of great skill. But Freud would like to be sitting where I'm sitting, and he wanted to be able to use brain science to help him with the psychology of dreams. But he couldn't, because there was no brain science in 1895. There is today. So I think that represents a remarkable opportunity, and one that foundations like Bial ought to take into account when they're thinking about their program, because this is a unique opportunity. Now, let me tell you a little bit more about the physiology of sleep before I go on to make the argument more interesting by considering why I consider dreaming to be prior to waking. When we study the physiology of sleep, either in humans and or in animals, we notice three things that are important. One, waking and dreaming are both associated with activation of the brain. So the brain is turned on in both cases. The brain is very active in both cases, and that's, of course, counterintuitive. You wouldn't think that in sleep your brain was activated, but there are certain parts of your brain that are more activated in Rem sleep than they are in waking. So the activation is what the two states have in common. What differentiates the two states are two factors so far. One is that the input-output gates are open in waking. You receive sensory information, and you can operate on the world, whereas in dreams, the sensory motor gates are closed. You cannot receive information. It's actively excluded, and you can't send motor signals back out into the world. So your activated brain then, in dreaming and REM sleep, is offline when compared with waking. Now those are two factors: activation A, input-output gating I, and there's a third factor, and that is the chemical modulation, factor M. A, I, M equals AIM. That's a three-dimensional state space model, which we can now specify quantitatively. And the chemical modulation is probably the most important part of the story, and it's the one that my reputation, I guess, depends most heavily upon. To our great surprise, the systems of the brainstem, the neurons of the brainstem, a little part of your brain between your ears. I tell people I spent 20 years of my life working on a piece of brain that's as big as my little fingernail, and that's really amazing. Just, it's so pathetic how little we know about the brain, and although I'm boastful about what I've learned, I'm also aware that this is just the beginning. And if it's the last frontier, it'll take us another 500 years to do this any kind of justice. But hopefully, the stuff that I'm telling you about tonight won't go out the window with the Freudian dream theory, which is, I think, completely wrong. Modulation then, let me explain it a little bit more. In order for you to be awake and understand this lecture, think about it, remember it enough so that you could tell somebody about it. You've got to be active with respect to your amenergic neurons. Now, amenergic is a funny word. You've never heard it, but it's the serotonin neurons, the norepinephrine-containing neurons, and the histamine neurons. All neurons that we thought might be more active in dreaming turn out to be much more active in waking. And they are subtracted from the brain when you go to sleep, and they are completely shut off during dreaming. So dreaming is a state of amenergic demodulation compared to waking. So factor M distinguishes dreaming and waking as radically as anything could be. Now, at the same time that the amenergic system is going down, the cholinergic system is going up. So the cholinergic system is held in restraint during waking, Otherwise, you'd be hallucinating right now as you listen to me, instead of 3 hours from now when you get in your bed and you stop the amenergic neurons from firing. The cholinergic system will go bonkers and wild, and you'll have these wild dreams. And that's all there really is to it. The brain has changed its mind because it's changed its chemical composition. As well as being offline, it is chemically altered. So it's an altered state of consciousness then, which is a function of changes in physiology. That doesn't mean that it isn't subjective. It doesn't mean that there isn't a mind. I think of the brain and the mind as a unified system. I think of the mind as being our subjective experience of the brain, and our brain being the objective experience of the mind. And in a way, when you take this point of view, you realize that subjective experience is the only way that you have of understanding your brain, because you don't really experience your brain in any other way than through your mind. And I think that subjective experience has been neglected as a method for studying the brain. And that's a radical position to take as well. But I think it's something that we ought to take more seriously. Now, I've told you so far then that I think that waking and dreaming are altered states of consciousness. I've told you a little bit about why they're similar and why they're different. Now what I'd like to do is introduce a concept that is, I think, extremely alien and very hard to grasp, and that is proto-consciousness. That's a term that I made up to try to capture the notion that maybe dreaming precedes waking, maybe dreaming is more important than waking in some respects, in preparing the brain to be awake. Now, proto also means before in time, earlier than. And there's abundant evidence that it is not only that day precedes night, or night precedes the following day, but also that Rem sleep occurs in the younger animal. In fact, it occurs most frequently in utero. It occurs before you're born, okay? So your brain is already self-activating when you're floating around inside your mother's stomach. And that's a really remarkable story, because what is the brain doing? It's making itself ready to be functional, to be more mature, and then finally to enable you to go to school when you get to be 3 to 5 years old. But it's a long process of development, and it's an active process. So what I'm telling you then is that dreaming, or Rem sleep at least, precedes waking by several months or years. It's not just that there is a night preceding each day, it's that in terms of our development over the long course in time, dreaming is the first state that we experience, or something like dreaming, what I call proto-consciousness, because I really don't think that fetuses dream, but I do think they might experience something. And when I use the term proto-consciousness, I then move ahead and define two different kinds of consciousness. One is primary, and the other is secondary. And primary consciousness, this is a terminology that Gerald Edelman introduced, is probably the kind of consciousness that we share with all the animals. Perception, emotion, memory, whatever, all of those things are probably ubiquitous mammalian phenomena. But secondary consciousness, language, abstraction, mathematics, science, literature, are probably exclusively human. They may be a few primates that come close to this, but secondary consciousness is a uniquely human factor. And I think that primary consciousness is what we get close to when we dream. Because I don't know about you, but I can't think when I dream. I don't think well at all. I have very strong sensations and perceptions, very strong emotions, a very strong sense of agency. The dream is always about me. I'm always at the center of the dream. And I think these are important formal features that must be instantiated very early in development, even in utero, that the fetus is already a sort of self, at least by 30 weeks of gestation. And that self agent moves in a space, just as I move in my dreams. I'm always in some space or other. It's always about me. And so my idea then is that at a very early stage in development, there is a proto-self that moves in a proto-space, okay? And it moves in the space and also feels in that space. The seeing and hearing and all the rest of the sensation is probably sort of prepared for in some way that we don't yet understand, but we can now at least begin to ask the question how that might occur. And interestingly enough, we also experience strong emotion. Now, emotion has been considered a symptom up until now. I suppose a lot of you think that anxiety is a symptom, but I say anxiety is not a symptom. Anxiety is part of the cognitive apparatus, that when you feel frightened, it's a very important feeling. And when you feel elated or happy, it's a very important feeling. When you feel angry, it's a very important feeling. And you're born with the capability of having all these emotional experiences, as well as having a sense of agency, moving in a space, and having the capacity to feel and to have emotion. So that's primary consciousness, and that's something that I think occurs in all the mammals, and all the mammals have REM sleep, okay? So again, it could be just a coincidence, but it probably isn't. It leads you to wonder, well, what is the function of REM sleep? And it turns out to be activating the brain as part of it, and I'll tell you about a couple of other parts as time goes on. But one part of it that's very surprising and completely counterintuitive is that temperature regulation depends upon REM sleep. If you take REM sleep away from an animal, and an experimental animal, he no longer can regulate his body temperature. What is body temperature doing for you? It's establishing a very narrow window for the operation of the brain. The brain does not function except in a very narrow temperature range. Think of yourself having either a fever or feeling cold, and you'll immediately appreciate how important this is. Because if you have a fever, you can't read, you can't think, you can't use secondary consciousness at all. And if you're cold, all you can do is try to get warm. So it's very important then for the organism who has a complex brain like mammals have to regulate body temperature. Now there's one other animal that regulates body temperature, and it's the only other animal that has REM sleep, and it is birds. Birds and mammals are the only animals that regulate body temperature. They are the only animals that have REM sleep. And in my view, they are probably the only animals that have something like dreaming in their experience, something like proto-consciousness. But all the other animals have primary consciousness. They just don't have secondary consciousness. Now, the thermoregulation story is part of a very important new approach to function that I've been taking with Carl Friston in London. Some of you may have heard of Carl Friston. He's a young, brilliant psychiatrist who is interested in free energy. And I didn't know what free energy is. Dick Bierman tells me he'll explain it to me tomorrow. But what Friston says is that complex systems, and brains are certainly very complex systems, have to be very careful about the management of free energy. And one of the ways they do this is to keep the temperature extremely constant. And I've already told you that that's an important function of sleep. The other thing that a complex system has to do to minimize surprise, to keep from going into a dysfunctional state, is to predict the consequences of its own activity. And the brain is doing this. The brain is not just copying the world. The brain is projecting expectations into the world. So that's what I mean by virtual reality program. All aspects of waking consciousness are in fact a projective experience, not just a receptive experience. So you project your model out into the world and you compare it with the information that comes into the system from the outside world. So the free energy notion then very strongly enriches the theoretical structure that I'm trying to sketch for you. That probably seems a bit obscure to you, but let me tell you that it's very important after 40 years of doing science on sleep and dreams to feel like I've got my hands on a functional hypothesis, number one, and on a theoretical structure to understand things. And none of these things could be expected by interpreting dreams. You've got to get away from that. You've got to think more formally. You've got to do physiology. Now, how can you test the theory? Well, it's a very difficult theory to test, but there is one very impressive phenomenon that enables us to begin to test the theory, and that is lucid dreaming. Is Steve LaBerge here? Hey, this guy put this phenomenon on the scientific map something like 20, 25, 30 years ago, and was a real pioneer in the establishment of the science of lucid dreaming. Prior to that time, certain people had written about lucid dreaming, and they were creditable people, but Stephen brought lucid dreaming into the laboratory, and what I'm telling you builds very strongly on his work. With Ursula Voss in Germany, we've been studying lucid dreaming using quantitative EEG measures. Now, you don't need to know what a quantitative EEG really measures, but it measures the electrical power under, say, 30 electrodes on the brain. And when a subject is awake, there's a lot of activity in the frontal part of the brain, okay? So secondary consciousness, I would say, is a frontal lobe function, all right? You've got to have your frontal lobe in order to know what day it is, know what to pay attention to, what to ignore, what to believe what I'm telling you or not believe what I'm telling you. All of these matters are secondary consciousness features, and they are frontal lobe functions. And you see this very clearly when you measure frontal lobe activity using quantitative EEG. Now, when the subject goes to sleep and enters REM and starts to dream, the frontal lobes are not reactivated. So no wonder you can't think, no wonder you can't remember, no wonder you can't direct activity. You are completely controlled by the automatic activation of the brain, and it's coming from the back of the brain. So lucid dreaming, Steve, is for me a functional split brain preparation in which the frontal lobe is out of the picture or comes back into the picture just as it is in waking. And so what it turns out that the frontal lobe activation of lucid dreaming is exactly midway in intensity between non-lucid dreaming, REM sleep dreaming, primary consciousness but no secondary consciousness, and waking with a lot of frontal lobe activation. And so it's exactly, it is both, the brain is both awake and dreaming at the same time. And I think that's a very exciting concept because we always thought that it was either one thing or the other, that you're either awake or you're dreaming. But now we know that you can be doing both. And that enables you to think about lots of things in psychiatry that are characterized by what is called dissociation. Dissociation is the linking of one set of characteristics to another set of characteristics that aren't supposed to be linked together. So the brain is capable of dissociation, and the brain dissociates automatically in lucid dreaming. And I think that's a very exciting part of the story. Now, there are some other things that we'd like to do to begin to test this theory, but what we need to do most importantly now is to make sure we've got the theory straight and then begin to think about other experiments that we might do to test it. In other words, what I'm telling you is that instead of thinking of dreaming as an unconscious mental state, think of it as an altered state of consciousness. Think of it as the only difference between dreaming and waking, the most impressive difference, is the failure of memory. But dreaming is very good at certain things that waking is very poor at. Dreaming is very good at imagining images. I don't know about you, but when I'm awake, I can't hallucinate. But when I dream, I do this very easily. Now, I use a language like hallucination because I'm a psychiatrist. You see what I'm talking about, don't you? I'm talking about mental illness. Dreaming as a model for mental illness, in which your capacity to hallucinate is increased, and your capacity to believe things that could not possibly be true is increased, but your capacity to evaluate those things, think about them critically, is decreased. And so we've also done a study in which we take normal subjects and we record them sleeping at home, and we've gotten something like 1,800 reports. And we score the reports for the presence of internally generated imagery, hallucinations, and a sharp rise from waking almost nothing to a very strong peak in Rem sleep. And then we also subject the same reports to measures of secondary consciousness thinking, and it goes in exactly the other direction. So just in the same way that the phenomenology, the subjective experience of sleep and dreaming is reciprocal, one thing going on, the other going off. The physiology is one thing going on, one thing going off. Also, the capacity to think, the capacity to have secondary consciousness as against primary consciousness going on and off. So we've got a three-way correlation going for us, and we're very excited about that. And basically, that's the story. I'm obviously ecstatic to be able to tell you that story, and I hope I've done it in such a way that's clear to you. And I haven't shown any slides because during those 9 lectures that I gave in Lisbon, I never got finished with anything. And now I think I've finished within time, haven't I, Mr. Chairman? And so let's have some questions. Yes, please. Anybody? Oh, come on. Do you really think this is true? Something like this has to be true. Something like this has to be true. Yes, Steve.
Well, thank you, Allan, for an interesting career, really. It's inspired me all along the way. I have to say, though, it seems your view of lucid dreaming is sort of reversed, that you're calling it a dissociated state, when in fact it is a state of increased integration. A state
Except
where,
for with waking reality. I mean, with waking...
Well, we, of course, are, while in Rem sleep, always asleep, meaning we're not in sensory contact, as you were saying, with the external world. When we are in a lucid dream, we don't become more in contact with the external world. We become more reflectively conscious, as you said.
And that's... we become hyper-associative, and we become, if you will, I guess that's what you're trying to get me to say, that you're in fact...
No.
You're not. Okay, well, I think you are.
I'm saying, I'm agreeing with your basic characterization of the regular REM sleep, which is to say it's a state of something like a dissociation from external input. But I'm saying what happens in lucid dreaming is not more of a dissociation, it is less of a dissociation.
I agree.
That's the idea. Well,
That's true.
good,
Okay,
good.
fair enough.
I'm not surprised, because I've often thought that we were having a language problem in our...
No, I agree with
yes, so we...
You could say that REM sleep is a good example of a dissociation. I would agree with that too.
Good. And so we can become perhaps more integrated in it, as you're saying, when we can somehow learn to be lucid. So, good idea.
Now, I don't mean to steal your thunder, but the fact of interpretation still hasn't been resolved. And I'm beginning to try to think about that. And I think that dreaming is hyper-associative, that remote associations are favored by this state. And that's what is strange about dreams. Things get tied together that you wouldn't think belong together, but they probably do, at least in terms of remote associations. So this stage of existence then is not only a preparation for reality in terms of giving you a virtual reality program, it enables you to understand the connections between things that aren't normally connectable. And it's probably also associated with scientific and artistic creativity. And I'm very excited about that possibility. Other questions, please. Yes, sir.
Yes, I'm wondering about the memory issue.
Yes.
When you wake somebody up during a dream suddenly,
Yes.
it seems to me that people do memorize.
They do.
So it's only the long-term memory that doesn't work.
Well, what you're doing when you wake them up, of course, is turning on the locus ceruleus, and you're turning on the serotonin raphe, and you're reinstating the memory system. And so what this actually, the important question is, why shouldn't you remember your dreams? Because the dreams themselves are not important. What is important is the brain state that is inevitably associated with dreaming. Now, that's not to say that dreaming is meaningless. Dreaming is extremely meaningful. My dreams are nakedly meaningful. They're all about me and about my doing all kinds of things that I won't want to tell you about. But if it's disguised censorship, if Freud pointed out, then he needs a new fig leaf, because I'm completely wide open during my dreams. And I think that this instantiation of identity of the self is another important part of the theory. That what you do when you go to sleep is you go back to the shop in a way. You go back to a stage that you experienced early in life, and you reinstate the genetic instructions that have been turned into an epigenetic program. Now, that sounds a little bit mysterious probably to you, but the geneticists tell us that brains are too complicated to specify. There is just too much information in a brain, 100 billion neurons. They have to be connected up with each other. The genome can't do this by itself. There isn't enough information in the genome. So what the genome does is to establish an epigenetic program, which is REM sleep, according to me, in which all of these connections are automatically made. And they're automatically made probably long before you dream, as you do when you acquire language. You have a scenario structure, and the fetus can't give a report, but the fetus is probably making all sorts of connections between nerve cells that take it far beyond genetic capability. So when we're talking about, behind or wherever, in front of the brain, we've got to look inside the brain, and just amazing stuff going on. Yes?
I wonder if I could maybe make Stephen LaBerge's point a little clearer by mentioning my own lucid dreams. I don't have them so often, but when I've had them, being as I'm a psychologist, I immediately, with the insight that I'm dreaming now, take full advantage of exploring the world, touching things, exploring it sensorily. And it's so obvious to me that this is as real as normal reality. So
Well,
a heightened
okay.
consciousness.
It's as real as normal reality.
Well,
sure.
and I have
Normal
access to
reality is
memory in the sense that
basically
I know I'm
conscious.
dreaming.
It's virtual reality when it's normal. I mean, the room is not inside your head. The images of the room are inside your head. And so you're using virtual reality right now. When you become lucid, you become aware that you're dreaming when you're dreaming, and you can actually control the plot and do lots of things that you can normally only do when you're awake. So I'm suggesting then that, you know, lucid dreaming is the re-injection of some parts of waking experience into the dream world. And I'm not saying that it's not real. I think they're both extremely real. And I think that your perceptions now are extremely real and extremely virtual. There's no room inside your head. There's only an image of the room inside your head.
I would like to know what do you think about the association.
Where is, oh, there you are, okay.
I would like to know what you think about the association between REM sleep and depression.
What is it?
The association between REM sleep and depression. Okay, in depression patients.
Okay, that's a
I would
very
like to
good
know.
question. I mean, I'll answer it at length, because the question is, what is the relationship between REM sleep and depression? The answer is that it's very abundantly clear that depressed subjects have an alteration in REM sleep propensity. They also have an alteration in the potency of their brainstem norepinephrine, serotonin, histamine, cholinergic systems. So there is a one-for-one identity then between the pathophysiology and the physiology and the phenomenology. The phenomenology is a little bit strange because dreams do not represent depressed affect very well. But the depression that occurs in normal life takes a long time to develop. It takes 3 weeks to develop. And when we record the depressed subjects in the sleep lab, we find that they have shortened REM latencies and increased intensity of their first REM period. Now that predicts the response to antidepressant medication. But the antidepressant medication may take 2 or 3 weeks to have its effect. So there's a synaptic level effect, which is immediate, and a longer energetic effect, which is probably due to second messengers or something we don't yet really understand. But I think the story of sleep and depression is pretty good. But the story of REM sleep and another psychosis is almost perfect. And that's organic psychosis. According to me, dreaming is an organic psychosis, because organic psychosis, which is associated with alcohol and drug abuse, is characterized by visual hallucinations, memory loss, confabulation, and what else is there? Everything about dreams is present in organic psychosis. So I think organic psychosis is in fact the expression, the readout of the REM sleep system into waking. And that, the interaction between the two is, I think, very interesting indeed. We've talked about lucid dreaming in which they're split apart. We've talked about clinical conditions in which they are, in fact, more closely linked to each other. But I just 2 days ago, I had a remarkable insight. You know, at the time of maximal occurrence of REM sleep, in sleep, is at 11 a.m.? You're awake at 11 a.m. You get up at 8. But if you were to sleep for any reason, the maximal chance of having REM sleep in sleep is at 11 a.m. Now, 11 a.m. is my maximal performance time. It's my maximal cognitive performance time. So the propensity that I have for REM corresponds exactly with my waking competence, which suggests to me that although the REM system is suppressed, doesn't express itself freely, I don't start dreaming, I sit at my word processor and I write a whole chapter in about 2 hours. It's amazing the flow of capability that is associated then with this period of the day. Now, there are people who are larks, and there are people who are owls. There are other people, some people who say they like the evenings best, but I think the mornings are by far the more common occurrence, and I think that's true. That's why we send kids to school in the morning, and we bring them home right after lunch. My kids are at home for lunch at 1 o'clock. So what is their peak time in school? 11 a.m. That's the time of the greatest propensity of REM sleep were they to fall asleep. So the REM system is at its peak at a time when maximal waking performance is going on. And I think that's paradoxical and very interesting. And I'm going to start to think about how I can do it.
Again, since this morning, I've already asked you this, but I didn't understand it exactly this morning.
So let's go.
Did you have a nice trip from Lisbon? I wanted to ask you, the biological, not the interpretation, I'm a biologist, so I would like to know your idea about if there is any vital function associated to lucid dreaming. So
with lucid, well, Steve,
lucid dreaming again.
I don't see that as being vital.
It's just another function?
I think lucid dreaming is a mistake. And I think dream recall is a mistake. I think that biologically speaking, lucid dreaming and dream recall are both mistakes.
Okay. Because this morning I was not so sure of your opinion.
I'm just telling you it's very rare.
Okay.
The spontaneous occurrence of lucid dreaming we've just studied in Germany, 600 German school kids, it peaks at about age 13 or 14. But it's a very weak effect.
Yeah, I know.
And I think, by the way, you're going to hear tomorrow from Bob Stickgold about difficulties of getting incorporation of learning. I think that's a relatively weak effect. I think what you go to sleep for is to reinstate the biological memory, the genetically determined selfhood, agency, movement of body in space, all the rest of it, all the stuff that's generic is extremely important.
So this is probably one more function of dreaming, lucid dreaming.
Well, it could be. I mean, again, I could be wrong about this, but I think lucid dreaming is a design error.
Yes.
Doesn't mean I don't like it. I love it. I'm a great lucid dreamer, by the way.
Have you encountered people that could dream in a mindful way, and this in the sense that they had a nightmare and then they suddenly see, oh, there is fear, and then detach from that fear?
You use lucidity to treat unpleasant dreams, by all means, definitely. And that's been done primarily by Rosalind Cartwright, who's a colleague of ours. But certainly, yes, this is my dream. You get out of my dream. Don't chase me anymore. Get away from me. Sure. If you're lucid and you know it's a dream, then you can start to exert plot control. And I think Steve would agree that that's
but you need lucidness there.
Of it.
You do need lucidness there?
You need a certain amount of lucidity to do that. Otherwise, you think that there really is a monster pursuing you.
Okay, thank you.
Monsters don't pursue you very often. And you can key on the bizarreness of dreams, the discontinuities and the incongruities, to tell yourself that you're dreaming while you're dreaming. That's the way I got lucid, was to use bizarreness as a cue. Steve introduces eye movements so people know they're in REM, because a red light flashes in their visual mask that tells them they're in REM sleep. So, however you do it, with pre-sleep auto-suggestion, use bizarreness or the nightcap, or the night, what do you call that thing? The dream light or whatever. Yes, you can do all those things.
Yes, you had a question.
Yeah, well, I might not entirely agree with you calling lucid dreams a state of dissociation. There is another state which actually gives support to your way of looking at things, and this is somnambulism. And there are a few cases, I think there are about 40 well-documented cases where people have done very complicated acts, some of them very violent acts.
True.
And sometimes totally out of accord with their normal character.
Yes.
I think Rosalind has written about some of these cases. How do you see these cases yourself in terms of your theory?
Well, we know that sleepwalking and sleep talking are not REM sleep events. They're not associated with dreaming as a rule. When we tether subjects, give them a long lead in the sleep lab, and they're sleepwalkers, and they get up and sleepwalk, they're in stage 3, 4 non-REM sleep throughout the sleepwalking episode. So they are dissociated in another sense. They have slow wave sleep or non-REM sleep in the cortex, and at the subcortical level, they're behaving perfectly normally. I used to get up and go to the bathroom. I'd go down the stairs, outside into the garden, and take a piss in the garden, and then go back to bed. And I never woke up. I was in stage 3 or 4 the whole time. And it was a very carefully and convincingly, clearly guided behavior. So I think that non-REM sleep is also subject to dissociation, and sleepwalking is a good example, it seems to me.
So other questions? I have also some questions.
Please.
I am very interested, of course, in the physiology of the whole.
Yes.
And of how to validate some of these different ideas.
Sure.
And I think one thing, I'm not specialist on the field, I must say, but anyway, been following some literature and some discussions on the topic. One thing that I think is very interesting coming up, and probably you know much more about that, is the fact that when you record, the brain activity in human beings with multiple electrodes
yes.
implanted in the brain
yes.
in a chronic way, and instead of finding that sleep is the sleep images in terms of electrophysiology are not properties that are common and general to the whole brain,
yes.
but they are very local.
Absolutely.
And this is actually a new, relatively new finding, comes up because of the techniques now can give us some information about that. So
I've talked
in that sense, I think that we have to change also our ideas about
yes, we do.
How the physiology of sleep is really affecting, the behavior part of,
sure.
of it, the phenomenology, because we are not sleeping with the whole brain all the time.
No.
We are sleeping with some parts of the brain.
And this three-dimensional AIM state space model that I alluded to treats the whole brain as if it was only one thing. But obviously
it is not.
Many different things.
You agree with that?
Oh, sure. And I want to tell you that the MRI imaging studies completely confirm this.
Yeah, I do.
That in REM sleep, one of the areas of the brain that is activated at a higher level than that of waking is the amygdala.
Yeah.
So the emotionality of dreaming is associated with hyperactivity of the emotional brain, of course. What else is new?
Yeah. Well, there's another point I'd like to make. You didn't mention that word, although I think it was implicit when you discussed, when you talked about the early stages of development and REM sleep importance in the stages of development, is the word plasticity.
Plasticity, sure.
Plasticity of neuronal circuitry.
Well, you've got to get all these neurons wired up.
And that is
there are 100 billion neurons in the brain, and each one contacts at least 10,000 others. That's 10 to the 13 bits of information already.
Yeah.
That's a lot of information.
And again, that leads, to
the genome can't do this. So what you do is simulate waking. You activate the brain and you instantiate synaptic connectivity.
And in fact, what you do is that you are building up networks, which are really functional networks, which are necessary, to the brain functions, in
so sleep then is anything but a throwaway, anything but something that doesn't matter downtime. the sleep is very important, and I guess that's...
And if you look at the neurophysiological side of it, there are two, well, not only, I mean, this question of high-frequency activities in the frontal cortex, etc., but also the so-called Lambda waves of the occipital cortex, which indicate, I mean, that indeed this is really essential, I mean, to the development of vision.
Absolutely.
And that's, again, another aspect.
So rapid eye movement sleep is called rapid eye movement sleep because they're rapid eye movements. And they're rapid eye movements in all of you right now. You couldn't see unless your eyes were moving. Are you aware that that's the case? No, because you see the visual world is stable. But your eyes are moving at 20 times a second. So your brain must be recomputing the image 20 times a second in order that the room would stay still in the face of moving eyes. And this is the part of the predictive aspect of the free energy theory that I mentioned to you. And the brain does this by, when it commands an eye movement, it sends a message to the visual thalamus and the visual cortex that the eyes are going to move to the right, and please correct the image for that amount of movement. It's very impressive. And so I think that that's still another reason for taking seriously the notion that dreaming is in fact a preparation for waking. And I bet all of you would like to go dream right now, wouldn't you?
So I think that after this statement, I mean, I think we can adjourn now to tomorrow, and we'll hear more about lucid dreaming in some of these coming days. So thank you very much, Allan.
Thank you for your attention.